Greetings, class. I hope I find you well. This is now episode 2 of our revision, November 2014, paper 1. So we are moving to question number 14. It reads, prove that sec 2 theta plus tan 2 theta is equals to sin theta plus cos theta all over 2 cos theta minus sin theta 4 marks. Right, so we can prove from the left-hand side. We want to make the left-hand side similar to the right-hand side. Right, so what you need to understand is sec theta is identical to 1 over cos theta. You also need to be aware that tan theta is good as sin theta over cos theta. Those identities are very important in order to prove this question. So since we have sec 2 theta, it means sec 2 theta is equals to 1 over cos 2 theta. Since sec theta is equals to 1 over cos theta, sec 2 theta is equals to 1 over cos 2 theta. Then you put plus. Tan 2 theta is good as sin 2 theta divided by cos 2 theta. Using the relationship tan theta is equals to sin theta over cos theta. Right, so you can clearly notice that we have a common denominator, which is cos 2 theta. Hence, cos 2 theta is going to represent our LCM. Something like this. So cos 2 theta and cos 2 theta, if we've got a common denominator both sides, you simply add the numerators. So we now have 1 plus sin 2 theta on the top. Right. So these are double angles. The double angle for sin 2 theta is 2 sin theta cos theta. Then the double angle for cos 2 theta is cos squared theta minus sin squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sin squared theta. So cos 2 theta can be presented in those three forms. So if you look at your question, we need cos theta minus sin theta as our denominator. Hence, for cos 2 theta, I'm going to choose the first one, which is cos squared theta minus sin squared theta, since it rhymes with the cos theta minus sin theta on our denominator. I hope you are following, class. Right, so let me substitute. 1 plus, this is sin 2 theta, which is 2 sin theta cos theta, right? Divided by cos squared theta minus sin squared theta. I hope you are following, class. Right, so you can clearly notice that 1 can also be replaced by sin squared theta plus cos squared theta. You need to be aware that sin squared theta plus cos squared theta is good as 1. So I am placing sin squared theta plus cos squared theta. Then you put plus 2 sin theta cos theta all over 2 cos squared theta minus sin squared theta. I hope you are following. Right, so this entire expression on our numerator can be factorized or can be treated as a quadratic expression. If you have sin theta plus cos theta squared. If you are to expand sine theta plus cos theta squared, you get sine squared theta. If you raise this term by power 2, then to find the middle term, you say sine theta times cos theta times 2, which gives you 2 sine theta cos theta. And the last term is cos theta. If it is raised by power 2, you get cos squared theta. So you can clearly see that the answer that you get when sine theta plus cos theta squared is expanded is similar to the numerator here. So I'm going to replace all these terms on the numerator by sine theta plus cos theta squared. I hope you are following, class. So sine theta plus cos theta squared all over 2 cos squared theta minus sine squared theta. Right, so the numerator can be written as sine theta plus cos theta, sine theta plus cos theta. Since we have got power 2, it means the bracket is repeating itself twice. Then on our denominator, we can apply difference of 2 squares. Cos squared is a perfect square, sine squared is a perfect square. So square root of cos squared theta is cos theta minus square root of sine squared theta is sine theta. So on the second bracket, you put cos theta plus sine theta, applying difference of 2 squares. Sine theta plus cos theta is good as cos theta plus sine theta. So these two brackets, they cancel off each other, leaving you with sine theta plus cos theta divided by cos theta minus sine theta. So if you look at our question, this is the right hand side being required. So you write proved, then you are home and dry. Let us move on to part B of the question. By using the substitution u is equals to sine x or otherwise, find the exact value of integral of pi over 2 as your upper limit and 0 as your lower limit, cos x over 3 plus cos squared x dx. I hope you are following. Right, so the first thing to do when carrying out integration by substitution is to make the x the subject of the formula. So this can be achieved by differentiating the given substitution u is equals to sine x. So you are saying du over dx is equals to derivative of sine x is cos x. So du dx is equals to cos x. I hope you are following. Then you cross multiply, you get du is equals to cos x dx, something like this. So to make dx the subject of the formula, you are now dividing both sides by cos x. You are going to get du over cos x is equals to dx. So this is stage number 1, making dx the subject of the formula by differentiating the given substitution. Now on stage 2, stage 2 is change of limits. So I'm now converting the x limits to become u limits. So the upper limit is pi over 2. So we have pi over 2 here, and 0 is our lower limit. So we now need to find the value of u when x is pi over 2. So we go back to the given substitution. U is equals to sine x. You are saying u is equals to sine pi over 2. So you just need to make sure that your calculator is in radians. When integrating trig, we use the radians mode. So sine open bracket pi divided by 2, we get 1. So when x is pi over 2, u is equals to 1, right? Then you are now placing 0 on x. Sine 0 is 0. So it means 0 is going to remain the same. So this is the stage number 2, the change of limits. Then after the change of limits, we move to the substitution stage. We move to the substitution stage. So on the substitution stage, you want to make everything on the original question to become u. I'm going to put an integral sign first. This pi over 2 is going to be replaced by 1. And 0 is going to remain the same since the lower limit is not changed. Right. Then as for cos x, you can write cos x as it is. Then all over 2. 3 plus cos squared x. So I'm going to write 3 plus, then you put an open bracket so that you convert cos squared x and you write cos squared x in terms of sign. You get 1 minus sine squared x, something like this. You get 1 minus sine squared x, which is good as cos squared x. Then on dx, we are going to put the dx that we have made the subject of the formula, and dx is du over cos x, something like this. I hope you are following. So you can clearly notice that cos x and cos x, they cancel off each other. So if we cancel them, you'll be left out with integral of 1, 0 lower limit. Your numerator becomes 1. Then you say 3 plus 1 minus sine squared x. Since u is sine on our substitution, it means sine squared x becomes u squared. Then you put du. Now that everything is now in terms of u, we can safely integrate. So here, let us simplify our denominator further. 3 plus 1, you get 4 minus u squared. Then you write du, something like this. Right, 4 minus u squared can be written as 2 minus u, 2 plus u, using difference of 2 squares. So we now have 1 over 2 minus u, 2 plus u, using difference of 2 squares. So in order to factorize this, we can first of all partialize it. So 1 over 2 minus u, 2 plus u is identical to a over 2 minus u plus b over 2 plus u, something like this. So a open bracket 2 plus u plus b open bracket 2 minus u is identical to 1. So we want to use the elimination approach. When u is equals to 2, we'll be able to eliminate b for us to find a. So a is equals to 2 plus 2, placing 2 on u, is equals to 1. So this becomes 4a is equals to 1. Therefore, a is equals to 1/4. I hope you are following. Then when u is equals to minus 2, we'll be able to eliminate a for us to find b. So you write b is open bracket 2. You put minus, but u is minus 2. So you now have minus 2 is equals to 1. So 2 minus 2 is good as 2 plus 2. You get 4b is equals to 1. Therefore, b is equals to 1/4. I hope you are following, class. Right. So substituting this in our identity, we get integral 0, 1. A is 1/4, so you write 1/4 over 2 minus u. B is also 1/4, so you write 1/4 here over 2 plus u du. Then we integrate, right? So to integrate inverse functions where the denominator is linear, we make use of the logs or the ln. So you are saying 1/4, which is your numerator, is going to be divided by derivative of the denominator. Derivative of 2 is 0. Derivative of minus u is minus 1. Then you put ln modulus 2 minus u. I hope you are following. Plus 1/4, which is your numerator, divided by derivative of the denominator. Derivative of 2 is 0. Derivative of u is 1. You put ln modulus 2 plus u. Then you close your bracket. So we now have minus 1/4 divided by, you now have 1/4 divided by minus 1, which is minus 1/4. Ln 2 minus u plus 1/4 divided by 1, you get 1/4. Ln 2 plus u, something like this. So it's now bracket minus bracket, so that we substitute the limits. In the first bracket, we are going to put 1 on u. In the second bracket, we are going to put 0, the lower limit, on u. So if we put 1 in the bracket, you get minus 1/4. Ln 2 minus 1, you get 1, plus 1/4. Ln 2 plus 1, you get 3. Then in the second bracket, you get minus 1/4. Ln 2 minus 0, it's 2, plus 1/4. Ln 2 plus 0, it's 2. Something like this. So remember, ln 1 is 0. So since ln 1 is 0, minus 1/4 ln 1 is going to disappear. In the first bracket, will be left out with 1/4 ln 3. Minus times minus, you get plus 1/4 ln 2. Then minus times plus, you get minus 1/4 ln 2. So 1/4 ln 2 and minus 1/4 ln 2 are like terms, and they give you 0. So your final answer becomes 1/4 ln 3, leaving it in exact form as per requirement of the question. I hope you are following, class.